Hi everyone, this video is all about quadratics. Join me as we look at how to find the max or minimum, how to determine radicals and simplify them, how to use the quadratic formula, calculate and graph inverse functions, and what the discriminant can do and how we can solve things with the discriminant. This video is a complete overview of the quadratics unit in grade 11 functions, but if you're in grade 10, 12, or beyond, you'll still find this really helpful because a lot of the quadratics spans through all those different courses. The first of the 5 questions that we're going to look at for quadratics says, what are the coordinates of the maximum or minimum for each of the 2 functions shown? Now, it's important to note that this is already in vertex form in part A. So a times x minus h all squared plus k. The a value is 3, which means that it opens up because it's positive. And the h and k represent the coordinates of the vertex. So that means the vertex is at 3, negative 3. And so if I did a quick sketch of what that might look like, you don't need to do something fancy, but just a quick sketch. So 3 and negative 3, somewhere around there. Then what I'm going to do is I'm going to draw a parabola that opens up. And what you can see there is that therefore it must be a minimum. And so we can say therefore it's a minimum at 3, negative 3. That's the coordinates of the maximum or minimum, in this case, a minimum. Now the second situation is not in vertex form. It's in factored form. And so what we have to do here is we have to let the y value, or f of x, be 0. When we do that, that's what's going to determine our x-intercepts for us. And so we're going to then say, well, that means that 3x minus 2 must be 0, or 3x plus 4 must be 0 in order to multiply together to give us 0. So we go ahead and we solve for each one of those. So 3x equals 2. Then we divide both sides by 3, and we get x equals 2/3. And then 3x plus 4 equals 0, so 3x equals negative 4. We divide both sides by 3 and we get x equals negative 4/3. But don't fear fractions. They're going to work out usually. And so what we're going to do here is we're going to find the x value of the vertex because that's always, due to symmetry, going to be the average of those two zeros, or those two x-intercepts. So we add them together, we divide by 2. And then what we get is we get negative 2/3 divided by 2. Well, just if you can't work that out in your head very well, think about it this way. You could write it like a division sign, and then what that means is we flip it and multiply. So negative 2/3 times a half, well, that becomes negative 1/3. So what we have to do now is we sub that back into our original equation, f of x, in order to determine what the y value of the vertex is going to be. So we go ahead and we sub in x is negative 1/3. We have everything else the same. And so what we're going to do now is we're going to multiply the 3 times negative 1/3 for the first and for the second. So 3 times negative 1/3 is negative 1 in both cases. And so we get negative 1 minus 2 and negative 1 plus 4 with a negative out front as well. So we get negative of negative 3 times positive 3. 2 negatives makes it positive, and we get positive 9. So that vertex is going to be at negative 1/3 and 9. Well, which way does it open? Well, we look at the a value. The a value is negative 1. We've pulled that a value out, it's been factored out in front. So because that a value is negative 1, that means it opens down. And so what we can do is we can then say that the negative 1/3 and 9 is a maximum, and there are the coordinates of the maximum in that particular case. Question 2 is all about radicals. And what you want to start by doing is just pause the video and see if you can write down all the perfect squares that we're going to be able to take out of the different numbers under the radical sign. So there you go. There are the perfect squares. 1, 4, 9, 16, 25, etc. And so what we want to do is we want to take out the greatest perfect square of 125. Well, 125 is 25 times 5. And so the greatest perfect square I can take out of 20 is only 4. So 4 times 5 is 20. So now I can write the square root of 25 as 5, and I can write the square root of 4 as 2. Everything else is the same. And so now 3 times 5 is 15. So 15 root 5, and 2 times 2 is 4. So 4 root 5. And now because they're the same radicals, I can add the number in front of the radicals. So I get 19 root 5. If those were not the same radicals, I could not add the numbers in front. Part B now, instead of being adding, has multiplication. And so in this case, we're still going to use the same process, but we're going to be able to multiply everything out at the end. So the square root of 98 is 49 times 2. And the square root of 8 is 4 times 2. And so what I can do is I can go ahead and write this out as, well, the square root of 49 is 7. And so I still have the square root of 2. And the square root of 4 is 2. And I still have the square root of 2 there as well. But remember, I'm not adding them together this time. So 3 times 7 is 21, root 2, that I'm left with there. And 2 times 2 is 4, and I have the root 2. And so now I can multiply the root 2's together, and I can multiply the non-radicals together. So negative 21 times 4 gives me 84. And then the square root of 2 times itself gives me root 2 squared, which is 2. So now negative 84 times 2 gives me negative 168. The third situation is a perfect square. A perfect square. Remember, if we have something like a minus b all squared, that's not just a squared minus b squared. It's actually like, if you think about foiling that out, first outside, inside, last, it has two sets of brackets. It gives you a squared minus 2ab. You have that middle term of minus 2ab plus b squared. So let's apply that in this particular case. Square root of 2 is a, so we're going to square that. And then we have the middle term, which is 2 times the square root of 2 times the square root of 3. And then the last term squared, root 3 all squared. So the square root of 2 squared is just 2. And then we have minus 2 times the square root of 2 times the square root of 3. We can multiply those together to give us root 6. And then root 3 squared is 3. So now I can combine the 2 and the 3. That gives me 5. And I still have the minus 2 root 6. I can't combine those because they don't have the same radicals. Now, question number 3. This says find the exact zeros of f of x equals 3x squared minus 12x plus 6. Determine the vertex and y-intercept, and then graph it. So the first thing I want to do in order to determine the zeros is I want to let the y value be 0, or the f of x be 0. So I'm going to go ahead now and I'm going to try to factor out as much as I can. Common factor, we always want to start with that because it simplifies our life. Now I get it down to this, and I try to go ahead and factor what's in the brackets. Try to find two numbers that add to negative 4 multiplied to 2. Not possible. So if it doesn't factor, what we have to do is we have to use the quadratic formula. And so I'm just dividing by 3 just so that we can clearly see the a, b, and c values. And so the quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So the a value is 1, that's the coefficient of the x squared. The b value is negative 4, the coefficient of the x, and the c value is 2. So now we go ahead and we sub these in. We always sub them in without the x, just the coefficients. Negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2. And that's all divided by 2 times 1. And so now I'm just going to simplify that. Negative 4 is positive 4 plus or minus the negative 4 squared was 16, and then we have minus 8. If we keep going and we simplify that a little further, we end up getting the square root of 8 under the radical sign. And we know from the last question we did that that's actually the square root of 4 times 2, and the square root of 4 is 2. So we can write that as 2 root 2. So x is equal to 4 plus or minus 2 root 2, all divided by 2. Now, in order to get it so it's not a fraction, I'm going to common factor a 2 out of the numerator here. So taking out a 2, we get 2 plus or minus 1 times root 2, which you don't need to write the 1 there. And now you can see that what happens is the 2 over 2 will cancel out. And so we just get what's in the brackets, which gives me 2 plus root 2 or 2 minus root 2. Now that is your exact zeros, but that's not helpful in order to graph it. So we're going to get some rounded answers here as well, 3.41 and 0.59, because that'll allow me to actually put that on the graph to see what's happening here. So the exact value is on the top and the approximate ones are below. So now what we want to do is we want to determine the vertex. And the x value of the vertex, if something is already in standard form, is just negative b over 2a. Because what we're doing is we're adding and subtracting a value from that. And it's pretty clear here. We're just adding root 2 and subtracting root 2 from that. So negative b over 2a, just I'll put this in to convince you that it's going to be 2. We get negative 4 divided by 2, which is positive 4 over 2, which gives me 2. And so what we can do is sub 2 into our equation now. And so when we sub 2 into our equation, we just replace the x's with 2, and we get 12 minus 24 plus 6. That gives me minus 6. And so that means the vertex of this is going to be at 2 and negative 6. So we've got the zeros and we have the vertex. The last thing it said was the y-intercept. So in order to figure out the y-intercept, we really just need to look at the equation. Because for the y-intercept, it's the non-x term, because when x is 0, the only thing that stays there is the non-x term. So if you wanted to, you could substitute x equals 0 into the equation to see that that worked. That's exactly what's happening. And this is, most of us can do this in our head because it just means all the other terms, like I said, are 0. gives me 6. So what I'm going to do now is I'm going to graph that on the grid on the right with all the information I've found. I'm just going to first give a scale here. I'm going to go up by every square being 1. So I'm not going to label every square because that might clog the graph a little bit. I'm going to label every other square. So my x-axis is on the horizontal and my y is on the vertical there, and I've labeled those. So now what I'm going to do is I'm going to label the vertex, 2, -6. Then I'm going to label those two zeros. They were 0.59 and 3.41. And then I'm going to label the y-intercept up there at 6. Now because of symmetry, we know that the y value will be 6 also when x equals 4. And that's because the vertex is at x equals 2, so the y values are going to be the same on both sides of that. So we go ahead and we draw our curve through those points, and we can label that with our function. That is the graphed function after finding all that we were asked. Question number 4 now says, determine the equation of the inverse of the function f of x equals 3 times x minus 4 squared plus 6 if x is less than or equal to 4. And that is very important for this question. It then says, then graph both f of x and the inverse on the same grid. So in order to determine the equation, we first let the y value be f of x. So we're just going to rewrite the equation with, instead of f of x, y. And we're going to switch x and y. That is what an inverse function does. It literally takes the x coordinates, makes them the y coordinates, and takes the y coordinates and makes them the x coordinates. So we now want to rearrange this equation for y. In order to rearrange the equation, we're going to use Bedmes in reverse. That's how we rearrange equations. So the first thing I want to do is I want to subtract or add something. Now in this case, I'm going to subtract 6 in order to get the 6 to the other side. So this gives me x minus 6 is equal to 3 times y minus 4 all squared. Now I have 3 times what's in brackets that follows. So I'm going to divide next. I'm going to divide by the 3. Whatever you do to one side, do to the other. That's going to cancel out the 3. And then I'm going to be left with just the y minus 4 squared on the right. Now I'm going to do that exponent. I need to get rid of the squared. So I'm going to take the square root of x minus 6 divided by 3. And it's actually going to be the positive or negative of that. And I'm still left with what was in the brackets, the y minus 4. Now, why is it positive or negative? Well, let me give you a simple example to consider. Consider y equals 9. Y squared equals 9, in fact. So if that was the case, then you could tell me that y could be either positive or negative 3 in order to be 9 when you square it. And so the same rationale works here. It's really just taking the positive or negative of the square root of 9. And that's what we're doing on the left side. So now we work at the brackets, which was y minus 4. And so we're going to add 4. And whatever you do to one side, you do to the other. I'm going to add 4 before the square root. It's just going to make it a little more clear to see that. So I would always do this when you do a inverse function. Always that last step of adding or subtracting the value, put it out in front of the radical. So we've got 4 plus or minus the square root of x minus 6 all over 3. Now keep in mind, the original function had a restriction that said x had to be less than or equal to 4. And because the inverse switches the x and y values, that means the inverse has to have a restriction on y. Y has to be less than or equal to 4. Well, in order for that to be the case, I can't add anything to 4. I could only subtract. So the inverse function is only the subtracting part of this, not the adding part of that. It's just 4 minus the square root of x minus 6 all over 3. And let's go to the graph and see how that plays out now, because it asked us to graph both on the same grid. What I'm going to do first with that is I'm going to go ahead and I'm going to make a scale. Every square is 1, but I'm not going to label every one again just so that I don't clog the graph. There's my x and y axes. And I'm going to start by graphing the original function. The original function had an a value of 3, and it had a vertex of 4, 6. So the a value is 3, positive 3, which means that it opens up, and the vertex was 4, 6. So let's go ahead and let's start by graphing the vertex of 4, 6. And then we have the restriction that x had to be less than or equal to 4. Well, that's only the left side of that quadratic. You see, I've continued it kind of like with a bit of a dotted line, but it actually only exists on the left side due to the restriction. So what we're going to do now is when we go to graph the inverse function, rather than trying to graph something with a radical in it, we're going to use the property that the x and y coordinates just switch. So the vertex of the original function f of x was 4 and 6. So that means that the coordinates of the vertex of the inverse function is going to be 6 and 4. And so swapping those around gives me that. And then also we had that y had to be less than or equal to 4, so it's the bottom half of a sideways parabola that opens from the point 6, 4. Now if you take that maybe one step further still, and you draw the y equals x line all the way up on the diagonal, you should be able to see that what's happened is the parabola has flipped exactly over the line y equals x, because the x and y coordinates have switched. So there you go. Number 5 says find all possible values for k if there's only one 0. F of x equals kx squared plus 8x plus k minus 4. So what would we substitute in for the both cases with the k in order to make that have 1, 0? Well, to have 1, 0, remember that the number of zeros is based on the discriminant. The discriminant is the value that's under the square root in the quadratic formula. So the b squared minus 4ac, if that's bigger than 0, has 2 zeros. If that's equal to 0, there's only 1 0. And if it's less than 0, there's actually no zeros, or 0 zeros. Now in this case, we have the situation where it's going to have 1 0. And so just remember there's the quadratic formula. And so it's that value that's under the square root. And if we have nothing under the square root, then we're not adding anything to negative b over 2a. And so that's why it just gives us 1, 0. So let's go ahead now and try to solve the b squared minus 4ac equals 0 case. We set that up first, and then we recognize what a, b, and c are. The a value is k. That's the value in front of the x squared term. The b value is 8, the value in front of the x term. And then the k minus 4 doesn't have any x with it, so those together are the c value. So what we go and do is we sub those into the b squared minus 4ac, and we get 8 squared minus 4 times k, a was k, and c was k minus 4. So what we need to do now is we need to expand this out and try to solve this. So 8 squared is 64, and then 4 times k is 4k, and then we still have the k minus 4 in brackets. Expanding this out one more step further, it gives me 64 minus 4k squared, and then the negative 4k times negative 4 gives me positive 16k. We are left with a quadratic. Who would have thought? So we're going to rearrange this now so we can clearly see the first term with the a, and then the b, and then the c. And we're going to go ahead and common factor a negative 4 out of that. So we get negative 4 times k squared minus 4k minus 16. And what we hope is that we can go ahead, once dividing by negative 4, and factor that. You can go ahead and try that, but unfortunately, it's not factorable. And that's why we have the quadratic formula that I've already listed on the right side. Now notice here that what we're trying to do is we're not trying to solve for x, we're trying to solve for k. So I'm just going to rewrite this instead of x, I'm going to write this as k equals those values. But we're going to go ahead and substitute the b value is negative 4, and then the a value is 1, and the c value is negative 16. It's very important you get the sign right. Otherwise, this is not going to be possible to solve. So we get k equals 4 plus or minus the square root. Negative 4 squared is 16. And then negative 4 times 1 times negative 16 gives me positive 64. So that's going to ensure that the value under the radical is a positive value. Otherwise, we couldn't actually find the square root, and it wouldn't have any solutions. Any real solutions, that is. Now, the root 80 is the square root of 16 times 5, and the square root of 16 is 4. So I can rewrite this as 4 plus or minus 4 times the square root of 5 all over 2. And now I want to common factor 2 out of this so that I can get rid of the 2 in the denominator and make that not a fraction anymore. And so now I can cancel out the 2 in the numerator and denominator, and I get 2 plus 2 root 5, or 2 minus 2 root 5. And so those are the exact solutions that are going to make 1, 0 here. And so if I take that and I sub that in for the 2 places the k value is in the equation up top, that will ensure that I have exactly 1, 0. Not a pretty number, but it's going to work exactly right. If this has been helpful, please like and subscribe. If you want more on how to graph quadratics, check out the video on the left. For more on the quadratic formula, check out the video on the right. Thanks so much for watching.